Mahi,
Yes, sir.
it's written in your notes, right? Good
Yes, sir.
conductors and bad conductors. So that one you read, huh?
Sir,
From there.
the materials which allow to pass heat through them easily are called good conductors. The materials which do not allow to pass heat through them easily are called bad conductors.
Yeah. Uh, why is like behaving like good conductor? Another one is not good conductor. Why?
Sir, the good conductors are they have like example is metal, like they have free electrons and that.
Yeah. They have free electrons in their structure, right? In their
Yes,
molecular
sir.
structure. Then they have the ability to transfer this heat energy with the help of these free electrons, right? That's why they are good conductors of heat, isn't it?
Yes, sir.
Yeah. Then we have conduction. What is conduction? Yeah, Monica. What is conduction?
The process in which heat is transferred in solids by
Hmm.
the vibration of molecules.
Hmm. Hmm. Very good. Very good. So there is one condition for conduction. What is that condition?
The solids should be in contact with each other.
Yes, very good. It's mandatory, huh? To be conduction, they should be in contact with each other, right? Then it is possible to conduct. Otherwise, conduction is not possible. Okay, then Adrita. Adrita,
Yes, sir.
how are you, Adrita?
I'm fine, sir. How are you, sir?
Thank you for your sacrifice and effort and to make the schedule to be in this batch. Thank you so much. Eh?
Welcome.
Yeah, and we actually uh, really uh, thankful to you, and we are really, feeling that our batch, with your inclusion, our batch is very much stronger now than before. Alhamdulillah. So,
Honestly, I feel really lucky.
yeah. So uh, today again we have Lamisa, another student. So her inclusion is also making us more stronger. We all together is strong, right? Than
Yeah.
before, inshallah. Then we had a discussion on convection, right? Before
Yes, sir.
in our last class. What is convection?
Convection is a process of heat transfer in fluids, in liquids, and in gases, both,
Okay, so why they are called fluids?
because they can flow.
They can flow, right?
Yeah.
Then uh, how how the convection process is happening? Like
In convection,
mhm.
like for example, when we are boiling water, the molecules at the bottom they get heated, their volume increases, therefore the density becomes lowered, and then since they're less dense, they rise up, and the molecules which have higher density they sink down, and then there is this circulation process.
Yeah, yeah, very good. So we also appreciate that your sound now is very much clear to us. Yeah, I
Oh,
think
thank you. I bought a new mic recently.
yeah, very good. That's really a very good initiative and very good action you did, and it's actually necessary for all of us, right? To have good, communication now in online. Without, good hearing or listening clearly is really tough, right, to communicate. Thank you so much again. Now, Farabi. Hello, Farabi.
Yes, sir.
Farabi,
Assalamu
how are
alaikum,
you,
sir.
Farabi?
Sir, Alhamdulillah.
So you are in Dhaka now, right?
Yes, sir.
Alhamdulillah. And how is your life going on now? You are missing your that last 1 month, leisure, right? Hello.
Yes,
Last
sir.
1 month you were enjoying a lot, and we were missing you. Alhamdulillah, we got you now. So Farabi, you tell us, uh, for convection, we gave two conditions. What are those conditions? Can you remember, Farabi, those two? Hello, hello, Farabi.
No, sir.
You can't remember. So anybody is there that you can say two conditions for yeah, only Adrita. What about Mariam Maimuna?
Yes, sir.
Yeah, two conditions we gave for convection.
Yes, sir.
Yeah, like
The
we said.
heating element should be at the
Yes,
bottom and the
yes,
cooling element should be installed at the top.
yes. Very good, very good. Example.
Example, the ACs in our classrooms and the cooking elements.
Hmm. Like the stove in our house.
Yeah.
That is, yeah, that is also heating element, right? That is,
Yes,
we
sir.
always install that one at the bottom, right?
Yes, sir.
Okay, so very good. You could get the point. That is the main important thing. Thank you so much. Then we have radiation, right? Mariam,
Yes, sir.
Mariam, could you please tell us something about radiation? Mariam, hello, Mariam.
Sir, she's having connection problem.
Okay, she is having connection. So you continue radiation, about radiation.
The process of heat transfer with the help of any medium, neither solid nor liquid, is radiation.
So without any medium, right? Yeah.
Yeah. Yes, sir.
Okay. The process of heat transfer without the help of any medium, neither solid nor liquid, and neither solid nor fluids. And if there is no solid, then there will be no conduction, right? And
Yes, sir.
if there is no liquid or any gas, there will be no convection. So there is radiation, the third process. It is transferring from sun to our earth, right? Isn't it?
Yes, sir.
That is the example. So these all things we discussed in last class. Now we are having more discussions. We have more four learning outcomes from this topic. Uh,
Excuse me, sir.
yes, yes.
Actually, I'm not at home. Actually, I'm doing class from my car. I'm somewhere else. So please, I apologize in advance if I get disconnected or something.
Oh, I see. Okay, thank you for informing. We are keeping in our mind that matter. No problem. Now we have these four learning outcomes left: E, F, G, H. So, Adita, are you in Dhaka now?
No, I'm not at Dhaka. I'm at Rajshahi. I mean,
Okay,
I've been here for the past 9 months.
okay, okay. So, you are in car in Rajshahi right now.
Yeah,
Okay.
at
So,
Nator specifically.
oh, Nator, Nator. Okay. Nator is very nice place. I went there.
Yeah.
There is Cholon Mill, big, one of the biggest mill in Bangladesh, Cholon Mill. Okay, so you have here EFGH, these four learning outcomes. I want Lamisa, our new inclusion today, Lamisa, to read these four learning outcomes, please. Lamisa?
Yes, sir. Describe the effect. Sir, E থেকে তো.
Yes, from me, E onwards.
Describe describe the effect of surface color, black or white, and texture, dull or shiny, on the emission, absorption, and reflection of the radiation.
Hmm.
F. Describe how to distinguish between good and bad emitters and good and bad absorbers of infrared radiation.
Hmm.
G. Describe how heat is transferred to or from buildings and to or from a room. H. State and explain the use of the important practical methods of thermal insulation for buildings.
Okay, great. Thank you so much. So we have here a very much important thing here, that is the color. The eh, the color, how it's affecting the absorption of heat. The black colors or any color like dark color, they are very good absorber of heat. If you are wearing the black clothes during the summer time, then you will feel really hot, because the color we have, that black color, that's absorbing sunlight, heat energy from sun, and that time we are feeling very hot. So it's not a good choice to use black colors or dark colors during the sunny day. And you if you wear the white things, white clothes, white covering, that time you feel comfortable. Why? Because the white things, they are reflecting back the heat, and that's why that heat cannot come to your body, and you are protected from the excessive heat. Okay, that's why when I went to Saudi Arabia, and also Mahi was there. Mahi, right? Hello, Mahi. You should
Yes, sir.
also help me to give the information. Like in Saudi Arabia, they are very much hot, right?
Yes,
Very
sir.
hot, very hot, and most of the places they are using AC, and their national dress is like
Tobe. Tobe.
thobe, yeah, thobe, and that is white color, right?
Yes, sir.
That is white color. Who is Muhammad Giyashuddin? Someone is named Muhammad Giyashuddin wants to enter in our class. Hello. Oh, I understand now. It's Sumaya. Yeah. Hello, Sumaya. Sumaya. Hello, Sumaya. Okay, she's coming. Maybe it's taking time to get connected with the audio. So we were discussing about the
Tobe.
national dress of the not only Saudi Arabia, there all the Arab countries where there is very much high temperature. That is UAE, then Qatar, Bahrain, Oman. All of them, they are wearing this type of white clothes, right? White covering
Yes,
also.
sir.
Also in their head, there is one scarf-like thing that is, also white color. So they are wearing this to get comfort, right, during the sunny day, isn't it? And Also, their houses, all the buildings there, mostly their outside of the building is white color. You can remember, right, Mahi? The
Yes, sir.
the buildings they have also mostly their outside colors. In our country, we have different colors of buildings, but in those countries we have mostly the white colored. The outside is white colored or like off white color. This way, they are making the uh, you know buildings outside, so that there is heat radiated and their house is not becoming that much hot. Okay, so these are the examples from our real life, and we understand that black colors, they are very good absorber of heat, and white color, they are good reflector of heat. Okay, so here one term is used, that is radiation. Radiation means heat. Okay, heat has another name, or thermal energy has another name, that is infrared radiation. What is that name? Hello?
Infrared radiation.
Infrared radiation. So infrared is the region already. You know about the electromagnetic spectrum, right? Mahi knows that, Monica, then Farabi, they know about it. Like red color, we are recalling that idea so that other students also can understand. Red color, uh, we can see. Then violet to red, Vibgyor, it is called violet, indigo, then blue, then green, then yellow, then orange and red. This all together, the first letter, if you take, is called Vibgyor. Vibgyor. So out of these seven colors, red color has the longest wavelength. Violet has the shortest wavelength, and these are called visible light. We can see them. Beyond these seven, the other electromagnetic radiation we cannot see. One of them is infrared radiation, thermal energy we are getting. We cannot see that, and its wavelength is more than red color. That's why it is called infrared. Okay, just above the red, uh, and more longer wavelength than red. That's why it is called infrared. Is it clear? Hello?
Yes.
Yeah.
Yes, sir.
Yeah, it's clear. So you will know another one, that is ultraviolet. Ultraviolet means that one has shorter wavelength than violet. That one also we cannot see. Ultraviolet. So we are now focusing in infrared. Infrared radiation, that is heat energy. Heat energy is absorbed by black color, and it is reflected by white or shiny color, shiny things, right? So dull means which one is not shiny. That is called dull. Dull color. And black you all understand. It is a dark color and deep color. So that is black. And we will go for the writings and notes later. First we discuss all these learning outcomes. Then we'll go for writing together. Huh? Then F. Before going to F, we welcome Sumaya. Sumaya, hello Sumaya. Sumaya, Sumaya, hello Sumaya. Sumaya, let's write a message to her so that she understands. Just a minute, huh? Hello, Sumaya. Sumaya. Hello, Sumaya. Sumaya, are you listening? Hello, Sumaya. Maybe she has some problem with microphone. Okay, now we are continuing then. Describe how to distinguish between good and bad emitters and good and bad absorbers of infrared radiation. So we have here opposite. Just one is just a previous one. What we got uh, like absorption, related to absorption or reflection. Now it's about emission. Like if any object has heat, when this object will emit or lose uh, that heat energy. It's also like for white color and white and black. Huh? So when the object is black, that time it is good absorber of heat. Again, when object is black, that is also good emitter of it. Then how it is possible? uh, which one is absorbing heat, that one is also good emitter of it. It is possible, like you think of a condition. Here is, for example, here we have one object uh, in a room. Okay, it is, for example, it is black. Okay, if this object is black and the surrounding temperature, for example, here we have 25 degrees Celsius. 25 degrees Celsius. Then this hot one, this is black and it is hot. This is a hot sphere. For example, it is 100 degrees Celsius. Then what will happen? It will be good emitter of heat, right? Because it has more temperature, then it will lose energy to surrounding area. We know the nature of heat, that where it is more heat available, from there heat goes to that area where there is less heat. It will transfer to that area where there is less heat. Have you understood, everyone?
Yes.
Hello? Have you understood? Hello.
Yes, sir.
Yeah. So
Yes, sir.
this is about the emission of heat. Now, if you think of absorption, during absorption, the situation or the condition will be opposite. Like here we have now 100 degrees Celsius, and here we have 25 degrees Celsius. That time, like this one will have less temperature. It is 25 degrees Celsius, and if the surrounding area has 100 degrees Celsius, then this black, yeah, the black one will then absorb heat. Is it clear? Hello, Mahi, Farabi,
Yes, sir.
then all of
Yes,
you,
sir.
Adrita, everyone understood it? So how the
Yes,
same
sir.
thing could be good absorber and good emitter of heat? That is the difference of condition or the context. Okay, so uh, E and F, they are correlated. Hmm. Here black is good absorber of heat and also good emitter of heat, and white is good reflector of heat and bad emitters of heat. Why white is bad emitters of heat? Because it's not allowing to heat to go out. It's reflecting back the heat inside it. That's why it's bad emitter of heat. Okay, so uh, we are done with F discussion. Then we'll continue now G. In our area, there is uh, you know religious discussion is going on. Like for some people, they arrange that is called Waz Mahfil. You know about this, right? In different area of our country, it's happening. So because of this, there is you might go get some background noise, right? It's very close to my house. Yeah, I close all the windows and everything. However, the sound is coming. So I am sorry for that. Maybe you are getting some background noise. Hello.
Okay.
Yeah. Then we have it's for 3 days. It is today is last day. Then G, we have here describe how heat is transferred to or from buildings and to or from a room. So this is about like now. Now we have winter, and during the winter we have cold in our surrounding area, right? Isn't it? So what we do, we try to stop, uh, like we try first we think that way, that we try to make our room warm, right? Isn't it? We try to make our room warm. How? We close the windows, we close the doors, and wherever it is possible, everywhere we try to stop the circulation of air, right? Isn't it? We don't allow the air to go out from our house or any air to come in from outside, so that there is no heat loss from our house. If there is heat loss from our house, then we'll feel cold, right? More cold. In this cold season, like I go to outside for some need or some work. I'm going outside during the morning or during the night. That time I can feel that outside is very cold. and inside the house is not that much cold, isn't it? Yeah, and inside the house we are cooking. From the kitchen, some heat is also coming to our house, isn't it? Hello, hello.
Yes, sir.
Yeah, so this way we try to, always we try to maintain a condition in our house so that there is less heat transfer from our room to outside. Other than this, we do some other purposes like uh, especially it is done in the where it is very hot or where it is very cold. In the cold countries, in their house they have double glazed window. You have heard about this double glazed window, all of you? Yeah, double glazed window means there are two parts. In the window we have two layers, and in between two layers there is trapped air. What is there? Hello, trapped air. And trapped air is very good insulator of heat. That means stop the conduction process. And as it is trapped here, so there is no possibility of convection also. So this way we are this way we are stopping the conduction process and convection process. There is another way, like in Saudi Arabia, we saw that in our country we have bricks. There is no hollow in the bricks, but in Saudi Arabia I saw that uh, the bricks are made inside that there is hollow. Hollow means there is space. In the middle of the brick there is some space kept so that air can be trapped over there when they are making the buildings. Mahi, you saw that? Mahi is there? The bricks in
Yes,
Saudi
sir.
Arabia, yeah. So that hollow is made to trap the air while making the walls of the buildings, and these walls at that time working as insulator, which one is stopping the conduction process also. Convection and conduction is stopped, so there is not possible to come heat from outside to inside. Then their room is becoming cold. Okay, in the hot region they make their room cold in this way, and in the colder region they make their room hot in this way so that they can stop the heat transfer from inside to out, outside to inside. Is it clear? So this is about the learning outcome G. Describe how heat is transferred to or from buildings and to or from a room. So we will discuss more about H. You join after 5 minutes, okay? All of you join after 5 minutes,
Okay, sir.
please.